So welcome, welcome. This is the STEAMSPort Robotics and STEM workshop sponsored by Black in Robotics. I am Carlotta A, and I'm a professor of electrical and computer engineering in the Lawrence J. Giacalotto Endowed Chair of ECE at Rose-Hulman Institute of Technology. This is in Terre Haute, Indiana. A lot of people have never heard of it, but it's about an hour west of Indianapolis, right in between Indianapolis and St. Louis. So we're going to do several things today, and we're going to wrap up with me giving you the details that you need in order to build an Arduino robot. A breadboard is a device that is used to build circuits in a neat and orderly way. And it gets its name, the formal name is a prototype or protoboard, but everyone just calls it a breadboard because people originally built circuits on a breadboard. So here's an example of one. It's a battery, a switch, an LED or a light emitting diode, it's like a light bulb, and a resistor. So the most basic type of electronic is the light, the LED. We call it the hello world of electronics. So if you ever learn to program, the first thing they always teach you to do is to print hello world to the screen. So in electronics, the first thing you're always taught to do is to make a light turn on. And people used to build them on breadboards with thumbtacks and wire. So that's how I got its name. Although now we use breadboards like this. So please find the breadboard in your kit and make sure you know where that is, because eventually we are going to use it today to build something. So a breadboard now looks like this, and it has things we call nodes. A node is the meeting point of circuit elements. So what that means is based upon the numbers and the colors, it tells me how things are connected. If you ripped it open, you would find these metal tabs inside. These metal tabs show the connection points because metal conducts electricity, okay? So what happens is anything I want to touch that is power, I put on this red column. Anything I want to touch that is ground or cold, I put on this blue column. We like to say voltage is hot, so it's red. Blue, ground, is cold, so it's blue. So the red and blue are called power rails. You got to have power to turn anything on. Just like you need power to turn a TV on, you need power to turn your robot on, you need the power for your electronics. In the middle is where we build our electronic circuits. Things we want to supply with power, we put in the middle. So if I wanted to build one with my LED, I put it in the middle and I connect it to my power. We can get power from either our microcontroller, which we'll talk about in a minute, or a battery, which I believe there's a 9-volt battery probably in your kit.
Yes.
Yeah, because there's one in my kit. Okay. All right. Breadboard. Once again, if I don't get questions, I'm going to keep the train moving because we got a lot to do today. Choo choo. All right. So on the breadboard, like I said, the red and blue lines give you your power. The middle give you your connections for your electronics. Things that are, you have to remember, and even my college students sometimes don't get this the first time, so it's okay if it's not all clear the first time through, is that these columns are things that can connect the power. These rows are things that are connected. So if I want some things to touch, I put them all on the red line or all on the blue line. Or if I'm in the middle, and I want things to touch, I have to put them on the same row. So 1A through E are things that touch on that row. 1F through J would be things that touch on that row. And there is this big divide or ditch in the middle where things won't touch if they're connected even on the same row. Okay, like I said, this sometimes takes a little while to get because even college students struggle with that. I mean, I don't want to say college students, engineering college students, I'll say that. Okay. All right. So if I tell you we're building something like these are all resistors or LEDs, and I want them to touch end to end is called series. End to end means head to tail. Then it looks like down here where I put 22 and 23 for one element. Then I put 21 and 23 for the next element. And then I would put 20 to 23. So basically, they all have to overlap at one number to touch end to end. That's called series. If you want your elements to be in parallel, which means they're all connected on the top and bottom, then you would put all of the top rows in 5, all of the tops in 5, and all of the bottoms in 6. That means they're touching on the top and the bottom. So this would be the head to tail arrangement, which we call series. And this would be like a side-by-side arrangement, which we call parallel. Okay, questions?
I do have a question.
Oh, yes, yes, yes.
So the parallel and the series, what are the different, like what's the difference in outcome for like something that's connected through parallel and something that's connected through series?
Good question. So if you connect things in parallel, they'll have the same voltage. So if I want to power a bunch of stuff so that it all turns on with the same voltage, let's say I use my 9-volt battery, everything in parallel with that gets 9 volts. If I connect things in series, they have the same current. So let's say I need all my LEDs to turn on, but LEDs will burn up with too much voltage. So I don't want to connect them all in parallel because if there's too much voltage, it'll burn out. But if I put them in series, they'll all have the same current, but their voltage will drop differently because different LEDs have a different rating. So they won't burn up, but they'll still turn on, right? So it's a matter of the device that you're going to use and how much voltage it can take and how much current it can take. Okay, because I need to give it enough power to turn on, but I want to give it so much that I damage it. Okay, so a lot of times assembling things are to make sure you're giving it the voltage or current that it needs and you're not damaging it so that it works. Okay, good question. I'm trying not to go too deep into some of this because I'm trying to give you exactly what you need and nothing more than this, like McDonald's and Burger King have it your way. So resistors, there are resistors in your kit. And the good news is the resistors in your kit are labeled. But I always like to go over this quickly because if you ever get to the point where you lose the labeling or the resistors fall out of the package, you have no idea what they are. You can always Google this on the internet, resistor color code as well to figure it out. But for example, if you have a 330 ohm resistor in your kit, then the colors tell you orange, orange, brown. That means 3 times 10 is 330 ohms. So the resistors in your kit, everybody should see if they can find some resistors in your kit. There ought to be some in there somewhere. They all have colors on them. Those colors tell you what size they are. All right. So we talked about that the LED is like a light bulb, right? It's like so the LED is in your kit. Everybody should find an LED in their kit. And LED is right here. Mine are in a little box. Yours may be in a different spot, but mine are in a little box like this. Yep. Those are LEDs. So when we get to that point, you're very good. When we get to that point, you're going to put one of those on your breadboard. Okay. So when we get there, you're going to put this on your breadboard, and our job is going to be to make it light up. That's going to be our first job today, to make that light up. Okay, everybody good? Type in the chat if you're not able to find any of this stuff. Tony, did you find yours?
The LEDs, yes.
Yes, okay. All right, so then what we do is the LED has a long leg and a short leg, and you want to put the long leg to voltage, and the short leg is going to go to ground through the resistor, and we're going to use that to turn on our LED today, okay? So here's what that basic electric circuit is going to look like. It's going to have a resistor, a battery, and an LED, but we're going to put ours on the breadboard. You could just connect it like this too. And then we're going to turn it on. This is for engineers, so don't even worry about that. What you think about is this picture here. Your battery can be a 9-volt battery, like I said, or it can be your microcontroller. So we're going to use our microcontroller to get the power from our computer to turn on our LEDs. Okay, are there any questions so far? Okay, let's keep going. The other thing you're going to learn about is a push button. A push button is like a switch. A push button is used to turn something on and off. To turn something on and off like a power button. So in your kit, you probably have this and this, and you have to put them together to make a push button. Actually, this is your joystick. Let me find it. This is a kind of push button too, though, but this may not be the one you want. Let me find the other push button.
It's the tiny little one, right?
Y'all have it's a switch. So what it does is it turns, let me turn the captions back on. I wish this would just remember and stay on. But so what it does is it closes and opens a circuit. So after we figure out how to turn the LED on, we can add a button so that when we press the button, it turns the light on, and when we let the button go, it turns it off. Think about like a light switch in your house. So that's what the push button will do. It closes and opens the circuit so that we can turn the LED on and off, okay? So what we're gonna put on the breadboard is something that looks like this, and then we're gonna use our microcontroller to make it turn it on and off. The other device I want you to find is called a potentiometer. A potentiometer is a variable resistor, and it depends. It could be blue. It depends. There's blue potentiometers, there's black potentiometers. Let me find mine. Unless one of you find it first.
Is this it?
Oh yeah. No, that's not it. That's a relay. Put that back. Yours is not blue. Sorry, it's not blue. It's silver. Hold on, I'm about to hold it up. It's silver. It looks like this big metal knob. It looks like a big metal knob. I don't know about now. I now want to show you a video of what it looks like when you put some of this stuff together, which is what you're going to eventually do with your kiddos. 1 second, because I want the sound to be on. So hold on. Where's my share button? Okay, so now we know what a breadboard is. My potentiometer is this blue box. So the thing you guys just went hunting for, here's mine. It just looks a little different. Here are the LEDs, here are my resistors, here are my wires. Okay, so this gives you an example of some of the projects you can do with the kids, right? So just by using those same 3 or 4 devices that I just had you pick out, you can do 5 or 6 projects. So that SparkFun Inventors Kit book that I had you download, these projects are in there. There's also another set of projects that come with the kit you got. They're not quite as explained as well, which is why I would suggest you start with that guide I had you download, because it gives color pictures and it goes step by step. The one thing that you guys may have to differentiate is some of their parts may look a little bit different than yours, like that potentiometer. okay? The one thing in the video that you saw that I didn't go over today, but you do have one in your kit, is right here. This is called a photoresistor. A photoresistor is a light sensor, okay? In your kit, you should have probably at least two, because I have them in my kit, two photoresistors. Yep, my Kiara is the finding queen. So they're in the box with the button. I'm sorry, they're in the bag with the button. They're in the same plastic bag with the button. And that's called a photoresistor. It's called a light sensor. So what you should have seen in the video is I would cover it with my hand to make something happen. So when you make it darker, so you can make a night light with that. It's called a photoresistor. So in your kit, they also describe ways that you can make night light by covering that and turning on the LED, okay? Any questions?
I like the Morse code. I was thinking about activities and stuff that we could do.
You also,
like,
not only do you have Morse code, but you also have an RFID device in your kit that you can use for sending secret messages to, where you can set that up and then the kids can program it to send a message that is hidden unless you look at the receiver. So because it's in mine, it's called an RFID device. If you think about it like at the grocery store kind of thing, things have like the barcodes on it. You know, you have to scan it to see what the barcode is saying. There's an RFID in your kit too that can be used for sending messages. But if you want to teach the kids Morse code, you can do that one where they have to actually just look at the lights and figure out what the message is too.
Okay.
Okay, let's keep going. So in Tinkercad, if we're going to build something in Tinkercad, what we're going to do is you put out a breadboard just like a real one, and we could turn on a battery to put on a battery, a resistor, the LED, and a button, and we can make a blink. So we're about to do this in a minute, but I want to show you the video first. We're going to do two Tinkercad activities, one with just the battery, one with the Arduino, and then we're going to go to your actual physical kit, okay? So this is what this looks like. I've wired it up. There's my button. And because I've given it a voltage, when I press that button, it turns on my light. I can do this in Tinkercad, and then I can go do it in my physical circuit as well, right? So this is what we're going to do. Then the next activity we're going to do in Tinkercad is, hold on, my internet's acting up. Okay. Here, let's just do this first. I'll show you this first. So here's one where you now put that's your potentiometer, that's your knob, and this is making a dimmer, like Tony said earlier. So now instead of me using the button and pressing the button to make the light turn on and off, I add the dimmer, and the dimmer makes it get dimmer and brighter. Does that make sense? So I'm now going to share my screen, and we're going to go to Tinkercad and do these two activities. Okay, so everybody go to tinkercad.com.
Yes.
Okay. So an embedded system is basically something that takes in an input from the environment and then puts out outputs to the environment based upon the world. Exactly what a robot does. A robot senses things about the world, makes a plan for how to act, and then acts on the world. An embedded system is a type of robot. The way you do this is by using your microcontroller, as shown here. We now know how to build a circuit without the microcontroller, but now we want to, instead of pressing buttons and turning potentiometers, we want the microcontroller to do this because this will also serve as the brains for our robot. So a microcontroller is an embedded system that takes in sensor data from the environment, sends out outputs. So it has pins on it. And based upon how you connect those pins, it either takes in digital data or analog data. So what you saw when we pressed the button was either on or off. That's called digital data. On or off, true or false. When you turn the potentiometer, it could take on any number along a number line between 0 and 1023. Any number along that real number line to make that fader is called analog data, analog data. Digital data, on or off. Analog data is anything along a real number line. In our case, your microcontroller would take in values between 0 and 1023. You guys understand that? Okay. So your microcontroller, even though I have Arduino Uno here, yours may say Elegoo, but it still has the same wiring. It has digital pins. There can be inputs or outputs. Your LED is an example of a device that can have either digital or analog outputs. If I turn the LED on or off, bright or illuminated or not, that's called a digital output. If I make the dimmer with your LED using analog pins, like when you saw when I did it with the potentiometer, you can make an analog output where instead of just being on or off, it can be brighter, a little bit dimmer, or completely off. That's called analog output. So that's why that's a good circuit to start with, because I can show you digital and analog inputs and outputs with those two circuits. Okay. The other things you will find in your kit, the microcontroller is powered off of your USB jack on your computer. But sometimes when you need to use several motors, it's not enough power. So when you start building your robot, you have to add additional power to make all the servo motors move, to make the stepper and DC motors move. You may have to put a power jack, or what we do on the robot is we actually attach a battery pack and we put in AA batteries, okay? But the microcontroller, for the things you do when you first start, your USB power on your computer is enough. Are there any questions? Okay. So I'm going to skip this slide because time is of the essence and I want to make sure we get something built. So once again, your Arduino microcontroller has inputs and outputs. 5 volts is high, 0 volts is low. That's based upon the microcontroller specs and also what your computer power port gives you. You have digital read to read high and low, digital write to write out high and low values, analog read to read in analog values, analog write to write out analog values. I'm going to skip PWM for now because it's a little bit too much for what we're doing here. And then we have some relational operators, but we'll worry about that later. So one thing we could do is we are going to now program your microcontroller to turn on your LED just like we did with the 9-volt battery, okay? And we can do this by using if conditions to also turn it on with a button. An if condition basically says, if I press the button, turn on the LED. Else, if I don't press the button, turn off the LED. Okay, is everybody good with that? All right, so now I'm going to do all this in Tinkercad. So go back to your Tinkercad screen. Stop your simulation. And now, instead of us building it, since you all know how to build, I'm going to show you the starters. So if I do Control A, delete, I can delete all this stuff here. I just want to delete everything on here. Control A, delete. Oh, why didn't Control A, delete work? Hold on. All right, click on all this stuff and delete it. And I'm going to show you the way to do this. Now that you know how to wire up a circuit, I'm going to show you things you can start with the kids with. Can you all see my Tinkercad screen?
Yes.
All right, clean off your board. Okay. Now, over here, if I open back up this window that had all my components basic on it, get back to, there's a little bit of arrow over here. If you click that arrow, it brings back your parts. So bring your parts back. Let me know when everybody's parts are back. Okay. Up here where it says basic, I want you to hit the down arrow. Up here where it says basic, click the down arrow. Go to Starters, Arduino. Starters, Arduino. And click on Arduino. You can start your kids with a pre-built board and the pre-built code and just let them run it and explain what's happening. So you're going to do starters, Arduino, and if I click on breadboard, I can slide the whole thing onto my space already built. So do that now. Starters, Arduino, breadboard. Okay. And it's already built. It doesn't have much on it yet, but that's fine. Let me know when everyone's done that. Okay. Now click on code up here. Next to start simulation, there's a button that says code, toggle code editor. Click on toggle code editor. Toggle code editor.
So we click on code and it comes up as blocks.
Correct.
Okay.
Now, what that is, that's the code to run the Arduino and program your board. You can do it with blocks or you can do it in Arduino code. The reason I have you start with the VEX is because I want you to see that these are the same blocks that you used in VEX. So this is a way to transition the kids from what you do with them in VEX VR to getting them ready for the Arduino coding. All this code does is it blinks a light on your microcontroller. So if you look at here, it sets the built-in LED to high, it waits 1 second, and it sets the built-in LED to low. That's all this code does. So if you run the simulator, this green light blinks on and off. Oh, no, I'm sorry. The yellow light blinks on and off. This yellow light next to G and D or ground blinks on and off. You see that? On your microcontroller, there's a yellow LED that is blinking on and off. It's on the blue microcontroller on the left. Next to G and D, next to the number 13.
Yep, got it.
William, Jarvis, haven't nodded yet.
Got it. I got it.
Stop your simulation and change your wait to 5 seconds. Change the first wait to 5 seconds. Change the first wait to 5 seconds and run it again. Only the first one. Change the first wait to 5 seconds and run it again. Now what you should see is the light turns on for 5 seconds and off for 1 second. On for 5 seconds and off for 1 second. Notice that there are several types of boards here, but this is good enough for what we're doing. Now, when you're ready for your older kids to start programming in Arduino, you go up here to that drop down and where it says change the edit mode, you change it from blocks to either blocks and text, if you want to see how they relate, or just text. We're going to do blocks and text so you can see how they relate. This changes it into Arduino sketch code.
And this is C or?
It's C.
plus?
It's like C++. It's actually at the top. It's C++ code.
Oh, okay, I see it. I see it.
Okay. So the way that this works is you have a setup function that runs everything once that needs to happen one time. And you have a loop function that runs things that have to happen multiple times. So you digital write the LED to high to turn it on. And because we made this a 5, it now says 5,000 milliseconds. 5,000 milliseconds is the same as 5 seconds. Okay. Then you turn the LED off and then you delay 1,000 to turn it off. Okay. What I'm going to do is, because I want to make sure, and we only have like 10 minutes left, I'm going to stop. You guys have the rest of the slides. I want to do this on your microcontroller really quickly. So before we get off, I need everybody to open up their microcontroller.
I have a question while we're doing
Yes.
this. When you write it in code, does it have to be in milliseconds or can you change?
No, it has to be in milliseconds. You have no control over that.
So the kids will
has to
need
be in
know the
milliseconds.
conversion. Okay.
Nope, yep, you gotta think about it. It has to be milliseconds. All right, so these are the two things everyone should have out right now, a breadboard and their microcontroller. Do at least one circuit with you before we hop off. Okay. All right, I'll let you look at the rest of the slides, and then William and I are gonna talk offline about how to make this into the robot, but I need to make sure you can do the basics here. Everyone should have these two things out. Yours may be bigger or smaller, but you should have these two things out.
Why is yours small?
Okay, now, get an LED to put on your breadboard. Get an LED to put on your breadboard, any color you want, any color you want. And just because I don't want this to take forever, well, no, it doesn't matter. Put it wherever you want, as long as it's in a different row. I'll show you where I'm putting mine. I'm gonna make it look like it did when we did it in Tinkercad. So here's mine. Put your LED on your breadboard. Each leg is in the same column, different row though. There's no numbers, so I can't give you numbers. All right, when you hold it up, I know we're ready to move on. Okay, now we need a resistor. Make sure it's a small resistor though. So
220.
320. Elliot, did you say 320?
220.
220. Yeah, get out to 220. Elliot said y'all have a package of 220. Get out to 220.
Yes. I don't think we have 320s.
Yeah, that's fine.
We got 330.
220. Elliot said you have a package that says 220. Because remember, my kit is different, so I don't have the same ones you have. Just get out the package with the 220.
You had it.
It was. So here's what it looks like now. Here's what mine looks like now.
This is not made for people with nails, I see.
Honey, you know engineering is cute. You better learn how to be cute while you wire a breadboard. Make them nails work for you.
Okay, so the short leg has to go on the row. That
They both on a row. They on a different row. Long leg is on one row, short leg is on one row. And then I just make sure that the row where the short leg is where I put my resistor.
Why my legs seem like they're the same way?
I might need to turn on my web camera and shoot down at my breadboard because I don't know if y'all get me. A wire from the long leg row. And you're going to put it to 13 on your board, okay? So find the number 13 on here. Find the number 13 on here on your microcontroller. I'm gonna have to hold this. That's on, I gotta hold it. So go and find the number 13. Okay, the number 13, you see? It says G&D 13, 12, 11, 10, 9, 8, digital IO. It's down one side. G&D 13, 12, 11. Put it in the one that says 13. A ref G&D 13. Okay. All right. So everybody have their wire in 13. The ground. Okay. So go to where it says G&D, G&D. Is probably right next to the 13. Okay. So on your microcontroller, you have two wires. One in 13 and one in G&D.
Okay, I have it hooked up on this one right here. And as soon as I hooked it up, it started flashing.
Yeah,
Okay, yeah, that's what I wanted you to see, but I don't have that one. I think that my kit doesn't have that one.
And it seems like this is the code. Turn on.
Okay, if you well, I don't know if this is right or not, but when I hit download, I had the software in there already. And when I opened it up in Arduino, it seemed to work.
Yeah, it should. That's why I'm trying to get me a microcontroller so I can show you that. But yeah, it
And
should.
then if you hit the left arrow, it's an arrow pointing right, which is like upload.
Yeah.
Okay.
So Jarvis is taking over now, but I think I'm gonna show it to you, but I think he pretty much knows what I was about to show you. No, you're right. You can change that code in your Arduino software, and that's what I was about to show you. So now plug it in and open up the Arduino software, and there's examples in there as well. So can you guys see my screen?
Yes.
So if you go to File, Examples, yep, that's exactly right. And then you go to Basics, Blink. File, Examples, Basics, Blink. That's the same code that's currently running. That's the default. It's always the default on a microcontroller. File, Examples, Basics, Blink. It's the same code we just looked at inside of Tinkercad. They commented it, but it's the same code, okay? File, Examples, Basics, Blink. Has everyone found that?
Mine has error messages on it. Is that supposed to happen?
No, but maybe we can figure that out. As soon as you open up your software, it had error messages?
No, when I did the
Try to download it?
when I did the Blink, the File Basics Blink.
That had error messages?
Yeah, it says error. It's a lot of errors actually.
Let's just leave it for a minute. I may have to take a look. It shouldn't have errors when you first open it because it's just opening up code. What's the error? I might have to take a look at yours. So now you want to make sure under Tools, your board that you have selected is the Arduino Uno. Tools, Board, Arduino Uno, and it looks like Jarvis is defaulted there.
Get board info.
Nope, Tools, Board, Arduino Uno.
Yes, yes. Okay, I see it. Yes.
Tools, Board, Arduino Uno.
Gotcha.
Then mine is not recognizing my board right now, but eventually it'll come up and say Tools, Port, and you have to select whatever port it recognizes. Maybe COM3, COM5, COM6, whatever it says, just click on it.
It has COM6 and Arduino Uno.
Click on Arduino Uno, COM6. Mine's on COM14 right now, okay?
Okay, so mine has a okay, let me first ask, because I have a MacBook and I have just USB-Cs and I did a doggle, I think this is what this is called. Does that affect anything?
No, but I'm not sure that software you download is the correct software for a Mac. That may be what the problem is. There's special.
Well, I clicked the Mac 10, iOS 10.
So then it should have worked. We might have to figure out what's going on with that Mac. I have a Windows machine. I don't know much.
I'll throw the Mac away.
This Mac costs a lot of money. I can't throw it away.
Okay, so now that you've done that, if you hit the check mark just verifies that your code doesn't have any errors. So you want to do that. Whenever you write code, you do verify first, so to throw errors if it's not correct. And then you want to click the right arrow to download your code. We want to make sure you can download code. You'll see a blue, yellow, and green light blink really fast. Well, I don't know about on yours, but you should see some lights blink really fast when it's downloading code. And then once it's downloaded, they'll stop.
Yeah, gotcha.
Now, your LED on your microcontroller and on your breadboard should be blinking. Now, if you go in and change that 1000 to delay 5000 like we did a minute ago, you should see it blink for 5 seconds on, 1 second off. I got to, maybe I can look at the regular terminate number. It's probably 800.
Did you try to charge your phone?
I'm trying to.
Oh, you're trying to
Got
get
it
it out.
right.
Oh, okay.
Yeah, but I'll call them today. I just called the maid on it, probably.
Okay, then.
Look it up by my name.
Okay.
Okay, did anything happen? Now, if
Mhm.
you upload that, you should see the LED on your breadboard blink differently.
Yeah, plenty of-
Yeah, mine isn't working.
Okay, Mike here, we're gonna wrap up in about 5 minutes, but I want you to go ahead and share your screen with me. I wanna do my last few wrap-up slides so we can get off, because I know people are getting hungry and need a snack and whatnot. So, so in the end, things you're gonna need to make your robot is there's an ultrasonic sensor in your kit. To make the obstacle avoidance robot, you are going to do the sonar projects in the Spark Fun book or on the Elegoo book, and learn how to use the sonar sensor, because that's what we're going to use for obstacle avoidance. It uses sound. It sends out a ping. It measures how long it takes to come back, and you can use it to detect objects. Then from that, you're going to build this robot. So the things you got to get, William, are these two DC motors and wheels. I can send you the links. They're on Amazon.
I think, yeah, I think we're good at wheels. It's just those motors and that.
Okay, I can send you the link for these motors as well. They're also on Amazon. You'll see in a minute in the video, the sonar is going to be here. And then you just have to attach it to something. Like this is attached to a breadboard holder. What I'm saying is you could just attach yours to a box of cardboard or a shoe box with some dual stick tape or dual lock. And you can make this, right? So you already have the breadboard. So you have everything on the breadboard, talking to the microcontroller. Then you just wire in the motors and you're good to go. So here's the video of that same one that my daughter was using at the beginning of the workshop. So this is the motor by itself. So you're going to use the links of the Sparkman Inventor kits as well as the Elegoo kits to see some of the other projects. I will do these after the Spark Fund though, because these projects are probably not explained quite as well. And then things you're going to need to make the robot is some kind of cardboard, maybe a shoebox, the 2 DC motors. You said you have the wheels, you don't need that. The dual lock and motor driver to create that robot. So I'm going to send you some links in a minute for that information that you need. And last, I just want to say thank you. Thank you. I hope you had as much fun as I did. If you get any of the projects working with you guys or you and the kids or you and the college mentors, college student mentors, please amplify our work on social media. That's how our mission is achieved when other people see what we do.